Hey everyone, I am Burhan with another tutorial on PCB designing using Kicad. In the previous tutorial, I described what Kicad is and I also discussed few of its features. We will try to learn more about Kicad in this video, particularly how to use some of its tools and navigate the program. From this video onwards, we will be exploring the Kicad features and tools by designing a simple circuit. This approach would make it easier for you to understand the things quickly. So the circuit which we will be designing is a transformerless power supply. Transformerless power supplies can be used for those loads whose current requirement is very low, like zero point 0.4 or zero point 0.5 amperes. So let's get started. You can start a new project by going to the file, create a new project, click OK, and open the schematic file. And now try not to lose the confidence by looking at the schematic editor's number of icons and tools. Let's start small and concentrate on a couple of tools at a time. Uh, you should draw your connections and schematics in this document. Now you can use a scroll wheel to zoom in and zoom out this document. Additionally, you have the option to pan across the document by using the right click and drag this document. Let me design a random circuit to explain different navigation icons. For that purpose, you can see this op-amp like icon or add a symbol icon. Just click on it and choose any random components. Let me choose battery. So here's the battery. Now click anywhere on the workspace and that window will again pop up. Let me choose a resistor. Sorry. For basic components like resistor, capacitor, diode, you don't need to enter the whole name. Rather, you would have to just type the first letter. So I will type R and here is the resistor like this. And I will again click on workspace. That window again pops up and I'll enter LED. Here it is. I'll click escape. Now, if you want to change the orientation of any component, just hover over it and click R on your keyboard to rotate that component like this. And similarly, if you want to do the same thing for this LED, just hover your cursor over it and click R. And if you want to move your component, hover your mouse over the component and click M. You can move your component. Similarly, go to R, click M, and it's done. Now I would like to connect all these components with wire. So for that purpose, you can see this add wire icon. I'll click on it and connect all the components. The random circuit is complete now. There are now a few features in this area. If you look closely at the taskbar, there are a few values. Let's start with Z. Uh, the zoom in and zoom out levels are indicated by the Z. Next, we have the X and Y values. These are the coordinates of the cursor that we are moving around the screen. Then we have dx, dy, and distance values. Let's look at some applications for the distance or how to calculate the distance between two distinct symbols. For instance, I can place the cursor on any of these symbols or components. Let me place it here and click 0. Now you can see that dx, dy, and distance values have become 0. And then I can move my cursor to the any of the other components. And you can see the distance between a resistor and LED is 12.9515. It's in mm. Since this feature may not be very useful in the schematic editor, but it will be very beneficial in the PCB editor. And now as I zoom in and out, you can see tiny spots where our cursor lands. These are known as grid points, and they are very helpful for joining two components together so that we don't have to mess around to connect them properly. Then there is this millimeter. It means that all of the values are in millimeters. Lastly, this option here shows the selected tool. For example, if I choose add wire, that will be reflected here. Similarly, if I choose add a symbol, that thing will be reflected here. On top, there are a few more navigational tools. You can see you can undo and redo any change you make by using these two buttons. Next is the find button. It allows you to look up items on the schematic. And you can see if I type battery, the pink color highlights the item once it locates it. The next step is find and replace, where you can look for the text and replace it with a new text by using the find and replace. We have some extra tools at the top of schematic editor which allow you to zoom in and zoom out. You can use the plus and minus symbols to zoom in and zoom out respectively. After that, we have zoom to fit. This will attempt to fit the entire document just like this on the screen. You can use the zoom to objects to make your schematic fill the entire screen. As a result, your complete schematic fits on the display. Now, what if you wish to enlarge a particular element or section of the schematic? Just click on zoom to selection and select that section. This concludes the minimum of navigation required in the schematic editor. Let's take a closer look now. We will begin with the tools on the left and move gradually over the tools on the right. I prefer to leave the grid on so I can see where I am placing the components and how they connect to each other. But this tool will help you turn it off in case you want to snap a screenshot or perhaps you just want a closer look at the schematic. Then these three buttons that we now have will assist in adjusting the document units. You can use the millimeter or inch, whatever you want. Additionally, we observe that has been reflected at the bottom here. I like to use millimeters, so in the upcoming videos, every measurement and computation will be made in millimeters. Next, we have the crosshair. Crosshair is the plus graphic that moves with the cursor. You can use this button to switch between the full screen and short crosshair wheels. Uh, you can use the full screen crosshair when you need to align two components. Next, we have a feature called as hidden pins. The hidden pins, which are typically made by power symbols, can be hidden or revealed by with the help of this button. The angle of the wire connecting two wires can be adjusted with the help of these three buttons. Normally, I keep everything set to 90 degrees, but if you want to try some new patterns, you can do that by just clicking on this icon, or you can switch the last mode to have an extra 45-degree option. Let me demonstrate it a bit. I'll click on this icon, delete this wire, and add a new wire. It will be connected in this way. And if I choose 45-degree, then it will be connected in this way. The turns will be 45, not 90-degree, which is the default setting. Then the next icon is automatic annotation. You can either leave this automatic annotation turned on so it automatically generates the number for new component, or you can turn it off and name all the components at once at the end of schematic designing. These names BT1, R1, and D1 are known as designators, and they are generated automatically by Kicad when you turn this option on. But I like to turn it off because I don't want to skip numbers if I delete something in between. Then there is Hierarchy Navigator, which we'll talk about in later videos because it can be a little difficult for newcomers to understand. So this much basic knowledge is enough to start designing our charger. There are some more features, but we will learn them side by side during designing. So let me delete the circuit.
This is the circuit diagram of our power supply. At the input end, we have a dropper capacitor with a bleeder resistor connected in shunt. After that, we have the rectifier, then the filter, then the voltage regulator, and then the output. So let's start by adding all the components. Click on this add a symbol icon. First, we will add a variable voltage regulator IC, that is LM317 IC. Here we have a lot of choice, but let's not choose any one from them. I will import the LM317 from Snap EDA to show you how you can import any component if that is not present in Kicad. Although Kicad has a very large component library, still there are some components which are not available in Kicad. You will have to import them from Snap EDA or any other website. For this project, all components, including the LM317 IC, are available in Kicad. But for demonstration purpose, I will import LM317 only. For now, let me add rest of the components. The first component is capacitor. So let me add a capacitor here and two resistors. First one is bleeder resistor and another one is protection resistor. The next is the rectifier section. For that we need to add four diodes. Although you can directly add a rectifier, uh, you have here bridge type rectifiers. You can use any of them. You can see the symbol from here. You can either directly use this bridge rectifier or use four separate diodes to make your own rectifier. I'll prefer to use four diodes. Now I need three more diodes. I will not go back to the window, rather I will hover my mouse over the symbol and click Ctrl D on my keyboard to duplicate the symbol. After the rectifier, we have the filter. For that, I will use a capacitor. After the capacitor, I'll use a potentiometer to adjust the adjust pin of our voltage regulator IC. Uh, Also, I need a feedback resistor. Now, in order to feed the input to the circuit and get output from the circuit, I will use screw terminals. Now I have added all the components other than LM317 IC. So let's import it. First go to snapeda.com. Then you will have to create your account here. But I have already created my account here. So I'll directly search LM317. Here are so many options, and you need to consider your data sheet and constraints before choosing any component. But since this is just for demonstration purpose, I will randomly choose any option because I just have to show you how you can import the files. I will not care about the datasheet right now, but this is not a good practice to download or to choose any component without taking its datasheet into consideration. Let me choose this option and let's see its symbol. We have its symbol and footprint. Let me download its symbol and footprint by clicking on this button. I will have to choose my tool. I am working on Kicad. There are some other tools like Altium, like Eagle, Fusion 360, but since we are working on Kicad, I'll click on Kicad. We are working on version 7, so I'll click version 6 and later. Copy the path and go back to Kicad. Click on this edit, delete, create, edit, and delete symbols icon. Click on file, create a new library. Now you have to either make the symbol as global or as project. Now what is the difference between these two things? If you choose global here, then you can use your symbol in other projects also. But if you select this option project from here, then you will not be able to use it in any of the projects other than the present one. Let me select project, click OK. Let me name it demo. It's created here. Right click on it, import symbol, paste the path, and it's here. So this is the symbol of our voltage regulator. Save it from here. Go back to the workspace, add symbol, and let me search for demo. It's created here, and here is our voltage regulator. Let me place it here. Now all components are here, so let me quickly do the wiring of the circuit. Okay, the wiring is complete. Let me add the ground from here. This is the function of hidden pins. If I click on hidden pins, you can see the ground appears here, and if I click again on it, the ground disappears. Here is a pin on potentiometer which is not connected to any component. We can use no connection flag here to tell Kicad that we have deliberately left this pin unconnected and it is not any mistake. Otherwise, Kicad will show error at this point. This way, our schematic is complete. But this is not a good way to make connections because if I return back the circuit after 2 or 3 months, it will be very hectic and cumbersome for me to extract information from the circuit. Moreover, if I am working for any organization, I can't share this design with my colleagues. Although the circuit is pretty simple, anybody can extract any information from the circuit. But think about the complex circuits. So in next tutorial, I will show you how you can make these connections in a beautiful way so that your design would become more readable and beautiful. At last, if you like this kind of content, you should think about becoming a channel subscriber. Thank you so much.